All right, we're ready. All right, now I want to talk a little bit about the states of matter when you change phase. Okay? Yes or no? We know that you have a solid, liquid, gas. Correct? And we know that we can go the other way. Now, those are seemingly very trite, almost, physical changes that you've known since middle school or even elementary school, yes? When you go from a solid to a liquid, it's called what? It's called melting, right?
Yeah.
When you go from a liquid to a solid, you call it freezing, right? When you go from a liquid to a gas, you call it what? Evaporation. Wouldn't you call it that? When you go from a gas to a liquid, you'd call it what?
Condensation.
Condensation. Yes? Which way is the energy flow? Left or right? To increase energy. I'm going to increase energy to the left or to the right? Increasing energy, guys. If you you're staring at me, it's really scary. To the right. Is that what you meant? Rashid?
Yeah.
Yeah, okay. So this is plus energy. What about this? What's this?
Negative.
Negative energy.
Minus negative.
Now, when you talk about thermodynamics, this is what you talk about. You ready? Here is a piece of paper. Is that coming out on the video? Here's a piece of paper. This is what's happening. This is the system. For instance, are you ready? Snow forming in clouds. This is snow forming in clouds. Now, the rest is the environment. And when you do thermodynamics, it's all relative to the environment. If, for instance, if this gives off heat, is that called exothermic or endothermic? That's called exothermic because the environment is heating, right? Yes? If it's absorbing heat, it would be endothermic. If something is cold to touch, this paper is the reaction, right?
Yeah.
It can be anything. My hand, this feels cold. What does that mean? Does that mean that it's cold or hot? My hand feels cold or hot?
It feels cold, but
It feels cold because energy is leaving my hand. My hand is the environment, isn't it?
yeah.
You get it?
Yeah.
It's always relative to the environment. Yes? So here I have the reaction. I'm saying the reaction is the formation of snow. Correct? Is that formation of snow, look at this. Is that formation of snow relative to the environment a warming process or a cooling process? Why is it warming process?
Because it's giving off energy
Why?
by forming snow in the clouds.
From water vapor
From more vapor, it's giving off energy to
make that snow. It's giving off energy. So it's going to warm the environment. So it's warming.
Yeah.
Right? It's exothermic, really, isn't it? You don't think of ice formation being exothermic, do you? But it is. Look right here. I'm forming ice. Look what's happening. You're giving off energy. This is relative to the environment, right? It's giving off energy. It's negative relative to the system, right? Isn't it? But it's negative exothermic. You're giving off energy. But relative to this and the environment is gaining the energy, right? You get it? What happens for clouds to form? What has to happen? Give me the sequence of events. For clouds to form, what has to happen?
Evaporation.
Evaporation, water vapor. Where's the water vapor come from?
From the ground.
From the ground. What has to happen to that gas, to that water?
To go to the ground.
It has to do what in order to rise?
To
It has to It evaporated.
Yeah.
Now what happens? It has to do.
Content.
It has to rise. It has to expand, doesn't it?
Yeah.
Doesn't it have to expand?
Yeah.
And it rises, right? And then what happens when it gets up top? It has to do what? It has to condense. How does it condense? What has to happen to the water vapor? It starts with a C. It has to. What did you say? Excellent. 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 Yeah, it has to cool. It has to chill, right? Yes? So it has to expand, rise, and chill. Now, is the formation of rain from water vapor, is that a cooling process or a warming process? I said that the cloud has to chill. But is it a cooling process or a warming process? Careful. Relative to the environment. This is the system now. We have a different system, right? We have condensation happening, right? Right? What has to come out of that water vapor in order for that water to condense?
Heat energy.
Yeah, heat energy. Kinetic energy has to be reduced, right, in the form of heat. Heat has to flow out. So relative to the environment, what kind of process is it?
It's a warming.
It's what?
Warming.
It's a warming process, right? Same thing, correct? Now, you're in the shower. A lot of steam. You get out of the shower. Really cold. How many people have suffered from that? Everybody raise your hand. So what do? You get wet. I'll go back in the shower. Thank you very much. Oh, that feels better. Woo-hoo-hoo. Why? Why? What's happening to the steam? What's happening to the steam? It's condensing, isn't it? It's condensing. Where's the energy going? It's going into the environment. Who's the environment? You are. So it's going into you. You gain energy. Is that hot or cold? It's hot. It's hot. Take your hand. If you don't know that, if you're confused by that, TJ, is that what you're talking to Andrew about? Excellent. I like that. You're being an active learner. Some learners are a little too active. So you put your hand in that fire.
Yeah.
Yes? You put it in there for like a half an hour. Yeah? Get some barbecue sauce, man. You know? You don't need a fork, man. It's right off the bone, baby. Little sauce, little Tabasco. For that to have cooked, what had to go into that hand? Heat. Heat had to denature the protein, right? When you cook an egg, the egg white is protein, right? What makes it turn white? It goes from sort of clear, kind of gooey, weird texture to white, hard white, harder white. What made it do that? Energy in the form of I'm stunned. Abdullah. Yes! Excellent. In the form of heat. Yes? And that heat is denaturing the protein. The protein is nice globular protein, and it's simply unraveling like this. And that unraveling appears white. It hardens. Yes? You get it? Locks it in place. Yes? Okay. So, what is a dog, what do we do to cool off? What do we do?
We drink water.
You drink water, good. What else? You sweat?
Yeah.
Yeah. Everybody sweat. If you're human, you sweat. It's a great test. What they do in the United States is an organization called, the CIA. And the CIA, they test for aliens. And what they do is, you could be an alien. Abdullah, sorry, but you could be an alien. That might be part of the problem, right? And they put you on a treadmill, and they see if you sweat. And if you don't sweat, you're an alien, sorry. So that's how the CIA, it's a true story. The CIA figures out whether or not you're alien if you sweat. Now, what does sweating do to cool you off? What does sweating do to cool you off? So now we're talking about what? We're talking about sweating, right?
Yeah.
And then what happens to the sweat?
Evaporation.
It evaporates. So now we're talking about evaporation. Is evaporation a cooling process or a warming process? You're confusing yourself. That's okay, TJ. Look at this.
Yeah.
I'm evaporating, so I'm putting in energy to the system. This is the system, right? Energy is going into the system, right? So where's the arrow going? Isn't it going into the system?
Yeah.
Right? Is that cold or hot? If you put your hand on something cold, that means energy is going into the board. My hand is the environment. The metal board is the system, right? So is that going to be cold or hot? Your hand. Your hand is the environment. Remember, we're talking relative to the environment. What is it? It's cooling. Yes or no?
Yeah.
Could be, maybe. What do you think? Yes or no?
Yeah.
Yes or no?
Yeah.
Yeah. Why anybody ever work on a farm or been on a farm? Yeah? Yeah? I love, you know what one of my favorite animals is?
Cow.
Who said that? Yeah, pig. I love pigs. I love pigs, man. What? Do pigs sweat?
No.
No, they don't. What do? They roll around in mud, right? What's in the mud that helps them? You said it like you're like a really science. I mean, he doesn't say water. He said moisture. I like that. And what's moisture going to do on the surface of the pig? It's going to cool it. So it's going to evaporate, isn't it? Yes? Let me ask you a question. Is boiling a cooling or a heating process? It's cooling, right? What happens to the surface of the water when something boils? What happens to the surface of the water? What happens? What happens? It gives off energy, doesn't it? Yes? It cools. It's cooling the surface. Yes? All right. So energy has to go in from the environment in order for it to evaporate. So this is evaporation. Evaporation is a cooling process, isn't it? But what is boiling? Does anybody know? Anybody know what boiling is? Does anybody remember? All right, I'll give you a quick bash on boiling, okay? You ready? Okay. And I know we did this. When water evaporates, it gives off particles of water, correct? Those particles of water have movement, right? And they're going to create pressure, yes or no? Yes or no?
Yeah.
Yeah, they're going to create pressure, vapor pressure, right? You have so you have this vapor pressure, and you have this atmospheric pressure, right? Yes or no? Okay, now. So we have vapor pressure, and we have atmospheric pressure. Okay, now. When something's boiling, what's most noticeable about water that's boiling? The formation of what? This is what I look like when I'm stunned. He's not dead, he's stunned, okay? So you form these bubbles. All right, here's a bubble, right? For the bubble to form, you have this pressure for the bubble to form. What's preventing that bubble to form before it boils? What's preventing it from forming? No? What's preventing it from forming? Isn't the atmosphere preventing it from forming?
Yes.
Yes? The atmosphere is preventing it from forming. But what happens when the atmospheric pressure equals the vapor pressure. What happens? Then you can form bubbles, right? Easy? That's all it is. That's all boiling is. That's all it is. When the atmospheric pressure equals the vapor pressure. Did you know that's all it is? I mean, it's all it is.
When bubbles form?
Yeah. And why can bubbles form? Because they're equal. They're equal. They can form. Okay? Now, so what happens? What happens? The bubbles are forming. Right? What about, when it's 1 atmosphere at sea level, it's 100 degrees Celsius, right? What happens if I go to the top of Mount Everest? What's the boiling point up there? It's like, I don't remember. Isn't it in your book, chapter 13? Isn't it in your book? Isn't it? Can you look it up, somebody? Okay, look it up. But what happens when you go up 19,000 feet? Or however, what is it, 35,000? What is it? What's the height of 29,000 feet, right? Ish. So what happens when you go up 29,000 feet from the sea level? What happens to the pressure? Does it get greater or less? Is the pressure on top of Mount Everest greater than sea level or less than sea level?
It's 71 degrees.
What is it?
71 degrees.
71 degrees. So Mount Everest, the pressure on top of Mount Everest equals 71 degrees Celsius. So what is the atmospheric pressure therefore less or more on top of Mount Everest?
Less.
It's less. So this equals, you don't have to put as much heat in. You don't have to get it to 100 degrees because the atmospheric pressure is low. Remember, it's when they're equal. So if this is smaller, then this can be smaller. If that's small, the amount of energy you put in can be smaller. Why is chlorophyll? Why is diethyl ether? Why is the boiling point of diethyl ether? I think it's in your book. Why is that so low? Why is the boiling point of diethyl ether? Somebody look up on their computer, and then we're going to quit. Somebody look up on their computer the boiling point of diethyl ether. Diethyl ether. It looks like this.
34.6 degrees.
Are you sure? Is it that low?
Yeah.
Okay. 34.6 degrees. What does that mean? The boiling point at 1 atmosphere, the boiling point at 1 atmosphere of diethyl ether is what?
34.6 degrees Celsius.
Diethyl ether. That's an ethyl group, right? Yes? That's ethyl alcohol. See that? Each line is a hydrogen. That's ethane. That's where the eth comes from, the ethane. Okay? So why is that 34.6? 1 atmosphere. 1 atmosphere. Why is it so low? Why is the boiling point so low? What characteristic of diethyl ether exists? Diethyl ether is what? What do you call it? How do you spell? What am I spelling? Look it up. Look up the word volatile.
Oh, flammable.
Look up volatile, not flammable, volatile.
Passing off highly volatile flammable liquid.
Evaporating, right?
Evaporating, how do you spell it?
Evaporating?
Volatile.
Oh, V-O-L-A-T-I-L-E.
A,
Yeah, T-I.
There's an L after
It's
it.
Yeah.
VOL.
Sorry, what?
It's
Yeah, volatile. Yeah, I knew that. I know. I wanted to put the T first. I'm sorry. I just do everything backwards. How do you spell it?
A-T-I-L-E.
Volatile. Okay, volatile. That means it evaporates rapidly at room temperature. It evaporates rapidly, much more than water does. Water should be much more volatile than it is. What makes water, chapter 15, what makes water not very volatile? Yes? Oh my God, Martha! The 9th grader comes on the board, blows everybody away. The dark horse wins the race. Excellent. Well done. Didn't even have to wait for that answer. Hydrogen bonding. You got it? Okay. Hydrogen bonding. Luna, you should have known that. He's busy playing video games. Is that what he's doing over there? I know, I can tell. He doesn't look stressed. Students that are looking at the computer in chemistry and don't look stressed are not doing what they're supposed to do.
I'm stressed.
Yes. You never look stressed. Okay. Did I say that out loud? Sorry. All right, so I think that's it. Is that good? Are we done? You've had enough. And Anna's looking at me like her eyes are starting to glaze over. Okay, I'm worried. I'm about ready to call an ambulance. She looks like she's ready to pass out, lose consciousness. You okay? But you're doing it very well, though. If you lose consciousness, losing consciousness with a smile is a good thing. Losing consciousness with a frown on your face is not good. Okay? We used to have to say, when I was an EMT, we used to have to say, we would put LOC or NLOC, loss of consciousness, or N, no loss of consciousness. All right, guys, you ready? I'm done.